Hi there again. Today we're going to learn about finding the prime factorization of numbers. So the steps involved and how we can express them. We're going to learn about that today. And before we begin, finding the prime factorization, let's first define what's a prime number. So a prime number, I'm going to use this hash as the shorthand for number. A prime number is a number with exactly two factors. So think about the factors of a number and which numbers have exactly two factors. So let's start with the number 1. Is 1 a prime number? So 1 is equals to 1 times 1, and the factors of 1 is 1. So 1 is not a prime number. Okay, not a prime number. Not prime because it has only, because 1 has only one factor. Only one factor. So 1 doesn't work. Let's look at the number 2. So the number 2 is equals to 1 times 2, and you can see from here that 2 has exactly two factors. So 2 is a prime number, and so on. The next prime number will be, let's see, 3. 3 is 1. 3 is 1 times 3, so will be 3 is the next prime number. So the examples of prime numbers are 2, 3, 4. 4 would not work because 4 has more than two factors. Next one will be 5, 7, and so on. Okay, the next one is not 9 because 9 has more than two factors. It's actually 11, and then 13, and 17. Okay, and you could see from here that 2 is the only even prime number, and it's the smallest. Now we look at some examples. So find the prime factorization of, let's say, 72. Okay, and there are two methods. I'm going to list down the methods for you. So method 1, I'm going to use factor tree. So using the factor tree. So first of all, I will list down 72, and I am going to look at how I can break up 72 into factors. So I may want to try like 2 times 36. And you could see that 2, I can break 2 into factors, other factors, because it's a prime number. So I can circle it. It's because it's prime. And now let's look at 36. 36 can be broken up into 6 times 6. Is 6 a prime number? If it's not prime, then you can actually break up 6 into 2 times 3. And you could see that 2 and 3 are prime, and you can circle them. And the other 6 can be broken into 2 and 3. So you get 2 times 3. So from here you can see that 72 is equals to 2. How many 2's are there? Let's count. 1, 2, 2 2's, and 3 2's. So 2 times 2 times 2. And there are, how many 3's are there? So let's see. We have 1 3 and 2 3. So 3 times 3. So this brings us to, we can actually simplify this further, and we know that 2 times 2 times 2 actually is 2 to the power of 3, and 3 times 3 is actually 3 squared. So this is the answer. So 72 is equals to 2 cubed times 3 to the power of 2. So this is the prime factorization of 72. Now we're going to look at method 2, and this is the ladder method, and it's called the ladder method because it looks like the ladder, and some may call it the upside down division. So I'm going to look at 72 first. I write down 72 and I do like an L shape. All right, so let's look at, you must think about what are the prime factors of 72. So very nicely we know that 72 is even. I'm going to start with 2. So 72 divided by 2, you get a 36. And again, 36 is an even number, so you can divide 36 by 2, and you continue. So 36 divided by 2, you get 18. And if you continue to divide 18 by 2, you get 9. And from here, you can see that 9 is divisible by 3. So, and then you end up with 3 here. So from here, all these numbers here are prime. So you're ready to write down the prime factorization of 72. So 72 is equals to, and you could see from here that is 2 times 2 times 2 times 3 times 3. All right, and you can write down, you can list down all the factors individually and then write it as in the index form, or you can write it as 2 to the power of 3 because there are 3 of them there, and 3 to the power of 2. And here we got the prime factorization of 72. You can use whichever method that you find is easier, but I find the ladder method is really a lot quicker than the factor tree method. Now you will have to try this example on your own. Find a prime factorization of 100. So let's see. You can pause this video if you want to try this on your own and check your answers with my work. Okay, so if you're going to use method 1, which is the factor tree method, you know that you can break 100 into factor pairs. So I'm going to start with, say, 4 and 25. Okay, you don't have to break it up into the product of a prime number. You can just put it in 4 and 25, and from there you could see that 4 it has can be broken into 2 and 2, and the two numbers here are prime, and you can stop here. And for 25 it can be broken up into 5 and 5. So from here we could see that the prime factorization of 100 is equals to 2 times 2 times 5 times 5, and that gives us 2 square times 5 square. And if you're going to use the ladder method, I'm going to first write down 100, and you do the L shape, the upside down division, and you have to divide 100 by its prime factor. So let's start with 2 because 100 is even, and then 100 divided by 2 you get 50. So 50 is even, so you can divide it by 2 again, and you can divide, you get 25, and 25 you can divide it into 5 and 5. So again you get the same answer for 100. So yeah, so this ends my lesson on finding the prime factorization, and see you soon.